Hello everyone and a warm welcome back to Manstack playlist. If you are building modern, scalable web applications, React is your front-end foundation. But as those applications grow, so does the complexity of your state management. That's why today we are talking a critical step forward. We are diving into two of the most powerful tools in the React ecosystem. The one is useReducer hook and another one is custom hooks. So we are not just going to scratch the surface. We are going to understand the why, the how and the when for each of these tools. And most importantly, how to combine them to write truly elegant, maintainable and robust code. By the end of this session, you will be equipped to handle any complex state challenge your next man project throws at you. So let's start with a brief reminder of our foundations. When function components arrived and hooks were introduced, it was a major shift. React hooks are simply functions that let you hook into React state and lifecycle features without writing a class component. The biggest benefit is cleaner, more readable code. Hooks allow us to abstract stateful logic away from the presentation layer. So we replace the boilerplate of class component like component did mount and this.setState with simple function calls. This modularity means better unit testing and significantly improved component reuse. So we all started with use state and use effect. They are essential, but they have limitations. When state involves many related variables or transitions, that's where our advanced tools come in. We focus on useReducer for tackling complex state mutations and custom hooks for generic logic reuse across your entire code base. So let's focus on useReducer. It is a direct alternative to useState, but it excels in specific scenarios. It's the ideal choice when your state involves multiple related subvalues, require complex update login, is passed down deploy. It is excellent for use with the context API as passing the dispatch function down is often much cleaner than passing down multiple setter function from use state. The mental model for use reducer is drawn directly from the Redux pattern. Instead of setter function, you use a dispatch function to send an action. This action then tells a separate pure function, the reducer, how to calculate the next state. Let's look at the basic syntax. It's an array destructing assignment similar to useState. So they have given const state dispatch equals to use reducer comma initial state. The arguments are crucial. The first is your reducer function. The second is your initial state, object or value. There is also an optional third argument, the init function, which allows you to the lazily create the initial state. This is useful if calculate the initial state is expensive as the function is only run once an initial reason or initial render. So after this, let's move on to the reducer function concept. So the heart of use reducer is the reducer function, right? So if you understand this slide, you understand the hook. The reducer function is a pure function with a simple signature. So it takes the current state and an action object and it returns the new state. The most critical principle here is immutability, where we cannot change. So the reducer function must never modify the existing state, object or array. Instead, it must return a brand new object or array. If you mutate the original state, React won't detect the change, right? And your component won't render, leading to bugs that are frustratingly difficult to track down. So the action object is how you communicate what happened. At a minimum, it must contain a type property, typically an uppercase string like increment, so or add to add TODO. todo. If the action requires data to perform the update, say the text of a new todo item. That data is included in a property called the payload. So, so let us take an example. So the type is a key, and for that we are adding a string like add todo, a value, comma payload is a key value, and for payload key we are having a bimil value. This pattern forces you to centralize all state mutations in a single writable function, making your logic easy to read, debug, and test. Here are the current state, action object, new state. So let's move on to the user reduce in action. So a counter. Here we can see two codes. The one is the reducer logic. The another one is component implementation. So here let's see the user reducer pattern in action with a simple counter. So this example perfectly illustrates the separation of concerns. On the left, we have the dedicated counter reducer. On the left, we have the dedicated counter reducer function. It uses a standard switch statement to handle the action type. Notice that for the both increment and decrement, the reducer returns an immutable new state object. On the right, our components call useReducer to get the current state and the dispatch function. The component is now simplified. The buttons don't contain any calculation logic. They simply call dispatch with a clear. So they simply call dispatch with a clear descriptive action object like type increment. The component focus on the UI and the reducer handles the state machine. A clean, effective division of labor. So let's move on to the next slide. Use reducer versus use state. Choosing the right tool. So the slide helps us formalize the decision making process. The general rule is start with use state but switch the reuse reducer when it becomes more convenient. So the space complexity within use state is more simple primitives, strings, numbers, boolean. For use reducer, it handles complex objects and array where updates are independent. So coming to the state transitions, if one update depends on another part of the state, or if a single use action triggers multiple state changes, the use reducer is better. Why? Because you can handle all those changes in one place, right? So coming to the code structure, use state forces inline logic within your component. When coming to the use reducer, it externalizes the logic into a separate cleaner reducer function. So coming to performance and prop drilling, this is a key advantage when using use context to pass state updates down. If you use state, you have to pass down multiple setup functions. So if you use reducer, you only pass down a single dispatch. So this reduces the number of values in your context and is a more efficient approach when the state needs to be updated deeply into the component 3. So in summary, use reducer when state updates are complex. So coming to the next one, let's move on to introduction to custom hooks. So now let's shift gears to custom hooks. The need for custom hooks arose because developers often found themselves copying and pasting the same stateful logic. So, like managing an AJAX page or syncing state to local storage across multiple components. The core purpose is pure logic reuse. So custom hooks let us abstract the encapsulate any stateful logic. So we take the implementation details of state effect and context out the main component body. So the benefits are huge. We achieve greater modularity, better separation of concerns, and drastically improve testability. Your components become highly focused, which leads to cleaner, more maintainable code. So let's move on to the custom hook examples. So here we have two codes. The one is custom hook and the another one is simplified component. So let's look at the simple custom hook use counter. Here it is. So this is the left side, right? We define it as a function that accepts an initial value. On the left side, we define it as a function that accepts an initial value equals to 0 and inside the function that accepts an initial values. So inside it uses a standard built-in for so use state. So inside it uses a standard built-in hook use state. So we then define the specific operation increment and decrement which contains the actual logic for updating the count. Finally, we return the necessary values of count, increment and decrement. So now look the consuming component on the right. It does not know and it does not care. The user com user counter is using useState internally. It simply calls the hook, destructures the friendly named functions that is increment and decrement. So and uses that directly in its buttons. The component is now incredibly simple, focusing entirely on rendering the current count and writing up the event handlers. This is the powerful of abstraction in actions. Let's move on to the next one. That is nothing but sign energy, use reducer plus custom hooks. So this is where we bring everything together, right? Creating the ultimate pattern for reusable complex state management. The synergy between use reducer and custom synergy bit custom hooks is a game. So the for building sophisticated applications. So the first one is centralized logic, and the second one is reusable interface, and the third one is clean components. By combining the, we create a powerful state machine that is entirely self-contained and can be dropped into any component that needs that specific set of logic. So coming to the next one. So let us discuss about key takeaways and best practices. So the use reducer for complexity, which reach for it when your state involves multiple related pieces or when you update depend on the previous state. The custom hooks for reuse, use them to dry up your code. If you find yourself copying and pasting use state or use effect logic, it needs to be abstracted into a custom hook. Let's combine the for power. For complex reusable domains like a shopping cart or a multi-step form, wrap up use reducer logic inside a custom hook for the cleanest possible component interface. Remember this philosophy. Write components that are simple and abstract the complexity into reusable hooks. Thank you so much for joining me for this deep dive. If you found this session valuable, please make sure to keep following our Munchstack playlist for more advanced development topics. Happy coding, and I will see you soon. Thank you.